All right, so today is our last day of new material. So we're going to be talking about topics from 5.4 and 5.5. 5.5 if there's time. So before we get started on the new material, maybe we can talk about the fundamental theorem of calculus. So I've written it down here. Let f be continuous on the interval, closed interval from a to b. Then, if g of x is defined to be the integral from a to x f of t dt, then g prime of x equals f of x. And then the second part is if f, capital F, is any antiderivative of little f, then the integral from a to b of f of x dx can be computed by taking the antiderivative and evaluating it at b minus the antiderivative evaluated at a. Good. Now here's a quick question. In part 1 here, g of x is defined to be this integral such that g prime is equal to f of x. Well, that must mean that g of x is an antiderivative of f. Which antiderivative is it? Or is it a family of antiderivatives, or a possible family of antiderivatives? Is there an infinite number of g of x's that would work for this? Actually, in part 1, g of x is a particular antiderivative, because notice what g of a is. G of a is equal to the integral from a to a f of t dt, which is equal to 0. Right, and so g of x is an antiderivative of f such that g of a equals 0. And so therefore it is a single antiderivative. It's the antiderivative that is 0 at the point a. Conversely, or compare that to the second part here, and this is saying that this capital F is any antiderivative at all. Okay, so remember that when we were computing antiderivatives, we always had that plus c. So typically, when you're computing an antiderivative for an integral, you're just going to choose the antiderivative, choose f where c equals 0, right? So you don't have to put in c, but actually it's not going to matter what c you choose. Okay, good. Now, so that's just a few notes about the fundamental theorem that we might use today. So what we want to talk about today, the new topic, is the indefinite integral. So that's a fairly straightforward thing to define. The notation f of x dx with an integral sign is a general antiderivative. Okay, so that means that this notation means that you're going to want to have your plus c. So just a couple of quick examples. The integral of x dx is equal to 1/2 x squared plus c. So if you have the integral without any numbers, you're going to want to have the plus c there, or the integral of cosine of x dx is sine of x plus c. Good. And so, so if you see the notation with no numbers on it, no bounds, that means it's the generic antiderivative. Good. So I just want to be sure that we're paying attention here about the notation. So just a caution about the notation. What's the difference between the integral f of x dx, the integral from a to b f of x dx, and the integral from a to x f of t dt? Well, we just saw that this is what we might call a family of functions. Math vocabulary is friendly. This is a family of functions. And by that we mean something like this, right, where we add a c to the end of our general or our one specific antiderivative. Good. What is this? That's the definite integral, right? This is actually a number. So this isn't even a function, this middle thing. And what's this last thing? A single function, a single antiderivative. So it's a single function. Yeah, it's the function where g of a is equal to 0. Good. So that's the difference in notation when you're reading these questions in books. So be careful about the notation that you're using for your integral. Good. Okay, so one's a family of functions, one's a number, and one's a single antiderivative. All right. So now what we're doing today is really just trying out we're hooking up the, let's see, what was that, 4.9 to chapter 5 now. That was the antiderivatives from 4.9. So remember that from 4.9 we had a table of antiderivatives. And so of course, since our exam is going to be open book, you'll be able to use the table. Okay, I had to pause for a second to find the table. The table was on page 398 in section 5.4. So you might go ahead and keep that open while you're working through the homework and things. So you'll see things like, for example, the integral of x to the n dx, right, is x to the n plus 1 over n plus 1 plus c. And that's, of course, if n is not equal to minus 1, right, because then you would have 0 in the denominator. And then what happens if we do have minus 1? That would be this one, right? And so do you remember that the antiderivative is the absolute value of x plus c? Okay, so that'll be something that you'll see in the table. All right, so let's just do some examples of integration. Examples. How about if we integrate 3x minus 1 divided by the square root of x? And as you might have suspected, there's some algebra first, right? Just like when we were doing derivatives. When you're doing antiderivatives, be sure that you do all the simplifying algebra before you start. And so the algebra in this case, we can write this as x to the 1/2 power, right? Times 3x minus 1. And so that would be 3x to the 1 times x to the 3/2 is x to the 3/2 power minus x to the 1/2 dx. Now we can just integrate term by term. So that's going to be x to the 3/2 plus 1 is 5/2 times 2/5, and then there's a 3 times that, right? So notice that that's the inverse or the reciprocal of the power there. Minus x to the 3/2 2/3 plus c. So simplifying, right, you get 6/5 x to the 5/2 minus 2/3 x to the 3/2 plus c. Good. Oh shoot, did you guys find the error that I just made? Well, instead of redoing the whole thing, I'm just going to change the problem. Then we'll do this problem again. So how about square root of x times 3x minus 1? There you go. Okay, let's try that one more time. So that's what I get for doing this late at night. Okay, so that's going to be x to the minus 1/2 power times 3x minus 1. Are you guys shouting at me through your TV screens or your computer screens? So that's going to be 3x to the 1/2 power now minus x to the minus 1/2 power dx. Good. All right, and so now that's going to be x to the 1/2 plus 1 is going to give us 3/2 times 2/3, and then we still have our 3 there, right? Minus x to the plus 1/2 times 2 plus c. And we'll just take one more step to simplify a little bit. 2x to the 3/2 minus 2x to the 1/2. Whoop. To the 1/2 plus c. Pretty good. Okay. Let's see. Let's try one more of those where we have to do a little... Oop, I guess we're running out of time. We'll start with an example in the next video. See you then.